Okay guys, welcome to lesson 9.3. We're going to learn some additional log properties. And the purpose of these log properties is so we can combine logarithms together into one log. Sometimes you have an expression with two or more logs and you want to put them together. And so that's what we'll be looking at today. All right, let's go ahead and get started here. So as we do this, I want to review some basic exponential rules with you because the logs are going to have some matches to that. And the reason for that is because, as we said in lesson 9.1, logarithms are basically just the inverse of an exponential function. And so if there's some rules that apply to exponential functions, well, there's going to be somewhat of a match to that in the world of logarithms. So let's go ahead and see. So first of all, you guys know this rule pretty well, I'm sure. If you have x to a power of a being multiplied by x to a power of b, you could put these two x's together as 1 and just add their exponents up. Okay, so if I had x squared plus x to the 5th, it would be x to the 7th, right? Well, it turns out there's a matching rule to that in the world of logarithms. It looks quite different, but you'll see there is some similarity there. As you guys can see, we have two logs that are being added. I have log base c of m plus log base c of n. And over here, we can rewrite it as one log where the m and the n are being multiplied. So multiplication goes with addition. Multiplication goes with addition. Okay? And so the point here is that if you have two logs, you can put them together as one log if you take their arguments and multiply them together. That works if you are adding. Okay, so it matches the rule about exponents. Let's review another exponential rule. If you have x to the a being divided by x to the b, well, that means you can put these x's together as 1x and subtract their powers, where you do the top power minus the bottom power. And once again, there's a matching log rule for that. If you have, just like subtraction goes with division, well, over here, subtraction goes with division. And so if you have two logs that are being subtracted from each other, you could rewrite that as a single logarithm where the argument of the first one is being divided by the argument of the second one. Okay? That is our second log rule that matches exponential rules. And finally, we have this exponential rule. If you have x to the power of a, and that whole thing's being raised to the power of b, you can just multiply their powers together. Okay? So let's take a look at the log rule that matches that. So over here, just like raising an expression to a power can be thought of as a multiplication of exponents, well, multiplying two things can be thought of as a power. So if you ever have a log that's being multiplied by a number in the front or something, you could rewrite that as a log without something in the front and just take that number from up here and make it a power on your m or your argument there. Okay, so these are our log properties for the day. I will be calling this 1, 2, and 3 when I'm going through the examples today. So I'll say, like, oh, I use log property 1. That means I use this. But once again, those aren't what their official names are or anything, but that's just what I'm going to refer to them for today. So we're going to do a couple of examples. So here's example 1. It says, use the log properties to condense each expression. And what that means is to put the two logarithms together into a single logarithm. So I've got log base 2 of x plus log base 2 of y. Well, addition, according to property 1, can be rewritten as one log where those two arguments, x and y, are multiplied together. So log base 2 of x plus log base 2 of y is equal to log base 2 of xy. And that's property 1 that I used there. Okay, let's go ahead and take a look at another problem. This one has subtraction in it. So look at your properties that we were doing earlier. You can see that's property 2 is the one that has subtraction in it. And in that property, if you have two logs being subtracted, you could rewrite them as one logarithm, where the argument of the first one is being divided by the argument of the second one. And on this one, we can actually simplify it a little bit, because 8 over 2 is simplifiable. 8 divided by 2 is 4. So this would be a nice simple answer to write. However, this is acceptable as well. All right, let's go ahead and move on to number 3. So on this one, I've got a log that's being multiplied by a number in the front. So take a look at your properties and see which property you think might apply here. Not surprisingly, that's property 3. And according to property 3, if you have a log that's being multiplied by a number, you could take that number off. So you have just a log now. And you could put that number that was in the front of the log here as an exponent. Okay? And so that's it for that one. Let's go ahead and take a look at number 4. We're going to make them a little bit more challenging here as we go. This is a weird looking situation. But first of all, I want to start by rewriting this. If you ever have a number being divided by 4, that's the same thing as multiplying that number by 1/4. So I'm going to rewrite it basically to begin with. So instead of thinking of this as log base 2 of x divided by 4, I'm going to think of this as log base 2 of x being multiplied by 1/4. That's the same thing. Okay? Now, next, now that I've done that, I can see that this is a property 3 issue. Okay? Property 3 is the one where you have a number multiplying your log in the front. And as we said earlier, we could rewrite that as a single logarithm where this power in the front is written as an exponent. Now, we could stop here, but we could also write it like this, can't we? Because a 1/4 power is a 4th root. Okay, so I'm going to write it this way for this time around, but it's good to know you could write it this way also technically. Let's go ahead and move on to another problem. Okay, so now we're getting into problems that it has more than one property. So the first thing I'm going to do is I'm going to use property 3. Do you guys see why I can use property 3 here? According to property 3, I've got numbers that are multiplying my logs. And according to property 3, you could take these and make them become powers of the arguments. And so it would end up looking like this. Oops. So now I've rewritten, using property 3, I've rewritten this expression here to say log base 3 of x to the 4th power plus log base 3 of y to the 6th power. Now that I've done that, I'm also going to apply property 1. Okay, I've got two logs being added, and according to property 1, I can rewrite that as a single logarithm if I multiply their arguments together. So it's going to be x to the 4th times y to the 6th, just like that. And that'll be my final answer. Okay, now you might be wondering, does it matter if we do property 3 first and then property 1, or can it go in a different way? And the answer is no. This order, it has to go in this way. There's no way you could put these together first. You'd have to get the exponents here first so that the logs match. This log matches this log, right? But as long as they have these numbers in the front, they don't technically match. So you can't apply property 1 until you've got these numbers off the front. Okay, so let's go ahead and take a look at another example. All right, so we've seen this before. We don't like having it as log base 5 of x over 3. Instead, we want to rewrite these as fractions in the front. So let's begin by doing that. There's another thing that's odd about this that you're probably noticing as well. And it's that instead of having just 2 log expressions, now we've got 3 of them. All right, so there's that. And not surprisingly, we can go ahead and make this become a power on all of these things here using property 3. So we've got log base 5 of, I guess I won't write it as a cube root yet, x to the 1/3 plus 1 log 5 over y to the 1/3. All right, so there's my property 3. Now, property 1 doesn't have to stop at just 2 logs. According to property 1, if you have 2 logs that are being added, you could rewrite them as 1 log where their arguments are being multiplied. But the rule can be extended to include multiple logs. So if I have 3 logs being added together, I can still put all those together as 1 logarithm, so long as I'm willing to multiply all those arguments together. And there we have it. Okay, and that's property 1. Now, we could stop here, but I want to show you some interesting things that can come out of this. First of all, notice how they all have the same power. I can rewrite that in the following way. If they all have the same power, then I can just group them and put the one big power there on the outside. And another thing I can do is, since that's a 1/3 power, I can also write that as a cube root. So, how will it look on your test? My guess is they're going to write it like this. Let's see. I'm curious if I can see the answer or not. There it is. Yeah, so they're going to write it as a cube root. So we do want to take it all the way to that process where we can see it as a cube root. All right. So what did I do here? I changed it from division by 3 to multiplication of 1/3. Then I applied property 3 to make those multipliers become powers. Then I applied property 1 to make it 1 logarithm. And then I just did some stuff with exponents to simplify it. So let's go ahead and move into one more example here. Notice this one has ln, but it doesn't matter what the type of logarithm it is, whether it's a natural log, a common log, or just some other random log. The properties work no matter what. So same rules apply. In other words, property 3 will have me rewrite these in the following way. ln of 3 to the 4th power minus ln of 10 to the 12th power. And then according to property 2, since we have subtraction there, I can write that as ln of 3 to the 4th power. I don't like how I wrote that. We can rewrite that as ln of 3 to the 4th power over 10 to the 12th power. And this can't, I mean, you could do 3 to the 4th power, which is 81, but 10 to the 12th power is a ridiculously big number, and there's no point in writing it out, so they're just going to leave it like this. So there we go. All right. I think we're ready for some student practice here. So go ahead and pause the video. Let me bring up the problems real quick. All right, guys. So go ahead and try these 4 problems. And when you unpause the video, I will have the solutions up for you. All right. So on this one here, property 3 will have you move the 5 onto the u as a power and the 5 onto the v as a power. Property 1 will have us put them together as multiplication. On number 9, we would start by rewriting this 3 down here as a 1/3, moving it to the power of the x there, and then x to the 1/3 power is a cube root of x. So that's where that cube root comes from. And then applying property 2 here property 3, we can make this z to the 6th power. And since we have, there's our z to the 6th, by the way. And since this is addition, we can rewrite it as one log where those two pieces are being multiplied together. So there's that one. This one is a lot like the example I showed earlier, where you would, first of all, take all these off the bottom and make it as a multiplication of 1/3. And then you could apply that power to each one of these things. And then when you put it all together, you end up with this. And you might not have thought to multiply all these together, and you might have just left it like this, but apparently they did here. 12 times 7 times 11 is 924. So there's that one. Number 11 is a lot like number 9, so same explanation there. Let's go ahead and move on to our next set. Okay, so on example 2, we're going to be doing the opposite of what we just did on the last slide. On the last slide, we had 2 logs, and we put them together into one. On this problem, we're going to have 1 log, and our job is going to be to split it up into 2 logs. So for instance, on this one, I've got 1 logarithm where the arguments are being multiplied. So if you go back and you look at our notes real quick, you could see which one of the rules has the arguments being multiplied together, and that's rule 1. According to rule 1, then, if you have two arguments being multiplied together, you could rewrite that as 2 separate logs that are being added. So like I said, this is the reverse of what we just did on the last slide. Okay, let's go ahead and take a look at number 13. Notice here on number 13 we have a fraction in here. Look at your rules for the logs that we're learning today. Which one has a fraction in the argument? So you guys can see that's rule number 2. And according to rule number 2, if you have log base 2 of a fraction, you could rewrite that as log base 2 of the top number minus log base 2 of the bottom number. And that's actually good enough. That's actually good enough. We could stop there. But I do want to show you something if you wanted to get fancy. We can actually simplify this because we learned it last time in last class, right? We know that 2 to what power is 4? Well, the answer is 2, right? And therefore, this whole thing can just be written as 2 if you wanted to get fancy. All right? But this is fine, the answer that we have there. I'm kind of curious how they're going to write their answer. Let's see. Oh, they didn't. Never mind. That's what I made up. All right, let's go ahead and take a look at number 14. Here we have log base 3 of x to a power. So go ahead and take a look at your rules. Which one of the rules that we learned today has your argument with a power on it? You guys can see that's rule number 3, right? And according to rule number 3, a log that has an argument with a power on it, that power can be moved up to the front there. So that's going to be 2 log base 3 of x. And that's rule 3. Go ahead and take a look at another one. So now we're going to start doing ones that are a little bit more complicated. So notice here I've got 2 things being multiplied. I also have powers, but you might realize you can't apply rule 3. Rule 3 says you could take the power, right, move it to the front. The problem is you've got 2 separate variables with 2 different powers. So do you move them both to the front? No, not really. So you do and you don't. So here's what we do. The first thing we do is we're going to split it up. We have u to the 4th times v to the 6th. And according to rule 1, if you have an argument of that has 2 things being multiplied together, you could rewrite that as 2 logs that are being added together. So it's going to be log base 7 of u to the 4th plus log base 7 of v to the 6th. Now we can do rule 3 where we take these exponents and move them to the front of the logs. But we have to wait till now to do it because they have different letters, right? The 4 is with the u, and the 6's with the v. So we had to split the u and the v up first before we could do that. Okay, so there would be our final answer on that guy. Take a look at another one here. All right, I've got two things being in a fraction here, right? And according to rule number 2, when you got a fraction, you can rewrite that as two separate logs that are being subtracted, where you have the top one come first, the bottom one come second. Next, I can use rule 3 to throw these powers up to the front. And there you have it. Let's take a look at yet another. All right, now what makes this one different from the last one is that there is a power outside of this fraction. Now there's different ways to handle this problem, but the one that I think is the easiest is to go ahead and multiply this power in to the top and the bottom powers. I think that's going to be, for me, the most straightforward way to go about doing it. So here now we end up with a to the 6th over b to the 36th power. So if you ever have an expression in parentheses with a power on these types, what I'd say is go ahead and multiply the power in at that point. So now that we've got that, this is just like problem number 16 that we did. The first thing we're going to do is separate this up into two logs that are being subtracted because we have a fraction. And then we can apply rule 3 to take these powers now and move them to the front. Okay. Let's go ahead and take a look at another one. All right, now you'll notice this time we've got 3 letters, okay? Which means that, and these 3 letters are all being multiplied together. So each one of them is going to get their own log, according to property 1. We're going to have a log for the A, we're going to have a log for the B, and we're going to have a log for the C to the 5th, according to property 1. When you have arguments being multiplied together, you can rewrite those as separate logs being added. And I think I need to fix that last one there. It's C to the 5th power. And then I can apply property, what is that, 3. And I'm going to take that 5 off and just throw it to the front as a multiplier. And so that's what that one would look like in the end. All right. Go ahead and take a look at this. So square roots. How do we handle the square root situation? Well, the first thing you want to do with those is rewrite it as a power. A square root is a half power. So instead of the square root of xy, I'm going to have xy to the 1/2 power. The next thing I'm going to do is I'm going to apply the power to each variable separately. So the z is staying the same because the power was never on that one. But the x is going to be raised to the 1/2, and the y is going to be raised to the 1/2. Okay? Now I'm going to apply rule 1 to split each one of these letters up into their own logs. So we're going to have log base 8 of z plus log base 8 of x to the 1/2 plus log base 8 of y to the 1/2. And the next thing I'm going to do is I'm going to apply property 3, where I'm going to take these powers now and I'm going to put them in the front. And so I've got log base 8 of z plus 1/2 log base 8 of x plus 1/2 log base 8 of y. One more thing though, remember working backwards, and instead of leaving this as a half log 8, I'm pretty sure they're going to write it like this on the answer key for this test. Instead of half log 8x, they're going to write log 8x over 2. Same thing with this other one here on the end. So there's our final answer. All right, so now it's time for some student practice. All right, guys, so here is yours. Go ahead and pause the video, see what you guys can do, and when you unpause it, you'll see the solutions. All right, let's see what's going on here. Go ahead and study these and see what you guys got. And that's it. I think that's where we'll call it a day for today. So hopefully that was helpful, and we'll see you guys in class to practice this stuff a little bit more. Have a good one.